Right, I'm gonna try to go over everything that I taught last Wednesday. Microphone is picking up a lot of static, so I'm sorry about that. But I'll just do the best I can. So first up, I'm gonna just talk about the basic data types. These apply specifically to Python, but do have carryover into other programming languages. And this isn't all of them, but just the most important ones. So first up are strings. So strings can be whatever you want. They start and end with a quote, a single quote, or a triple quote. They are all equivalent. Some are just easier in certain contexts. For example, if you are typing a word with an apostrophe in it, it doesn't work if you're using single quotes, but using double quotes, it doesn't care about it because it's not looking for that character to end the string. So strings are just, can be whatever you want, but it goes in between quotes of some kind. Next are integers. And so these are any numbers, positive, negative, 0, whatever it may be. And finally, Booleans, which are either true or false. So basic data types are just, if you drill down into any complex object in Python, eventually you'll hit one of these. So they're kind of like the basic building blocks for anything that you're going to do. And I'll go into particularly strings and booleans in a little more detail here in a bit. I'll just leave that up for now. So the next thing is, so these are all values of some kind. Variables are what we store values in. In Python, you declare or set up a variable by just typing a name of some kind. So we'll say it's going to be my variable, and I want it to be equal to 5. So now anytime that I reference my variable, it's just going to have the value that I assigned to it. So you assign values with a single equal sign. What you're calling your variable is on the left of the equal sign, and what you're assigning to it is on the right. So go ahead, I'm going to comment this section out, which tells PyCharm, or whatever is Python, to ignore all of these lines, to not treat it as code, just to treat it as comments. So this is essentially where my program is going to start. So if I say print my variable now and hit run, it's going to output the value of 5. And so I'll come back to what this print is in a bit. It's a function, and we'll go into more detail about those. But just know that I type the word print, put what I want to print out in parentheses, and it just works. So my variable here is an integer. We could make it a string if we want, and run it again, and it'll print that out. Also, just a note on setting PyCharm up. So you just create a new project, and then whatever you call it, and just this uppermost level, just create a new file, new Python file. And that should throw it there. And then after that, up here you'll have it'll say edit configurations or something. Go ahead and press new Python. I've already got mine set up. And then change your script path to be the location of whatever that Python file you just made was. Hit OK, apply, OK. and then you should just be able to hit this play button and it'll run your code for you. Alright. Something else that's important about variables in Python is they don't have to stay the same type. So I can start it off as a string, my variable, and then I can change it to an integer, and for the rest of its life until I change it again, it's going to be an integer. So it just overwrites any previous values when I assign a value to it. So we should see it says 5. Alright, next up we're going to go over functions. Whoops. So functions are sections of repeatable code that you can reuse. So let's say I have a function that multiplies things by 2. I will set up, say I'm going to define a function. This is what I'm going to call it. And then I can choose any number of parameters to go into it and what they're going to be called. So I will just call it my parameter. And then I do colon and hit enter. PyCharm will automatically indent the next lines that are part of this function by 4 spaces or a tab. And then any code that's not a part of this function will go back to not being tabbed in. So that's how Python determines what is part of what. So in the function we can do whatever we want with my parameter. And change it to a string. And change it to, I can do whatever I want with it. However, since it says multiply by 2, that's what we're going to do. So we're going to say my parameter is equal to, or actually we'll say my new parameter is equal to my parameter, whatever's passed in, times 2. And then this function is going to return my new parameter. So every function can have a return statement, and it's just going to say this is what I'm giving back to whatever calls me. So that'll make more sense here in a second. So to use this function, we're going to use my variable. So my variable is 5. We want it to come back as 10. So we'll say my function variable is equal to multiply by 2, where I pass in my variable. And we're going to print out my function variable. So we should see the output being 5 and then 10. So I'm going to just walk through this a little bit. So this doesn't really matter now. So first off, we define the variable as 5. We define this function, something we can reuse, and then we call the function. So call it by doing this and passing in the parameters it requires. So the names don't have to match here and here. My parameter doesn't, and my variable. So we're just saying we're passing in this thing. For the purposes of this function, it's going to be called my parameter. We're doing something to my parameter and storing it in a value, and then returning that value. And so that value, in this case 10, is essentially being placed here. So this line of code is identical to this for our purposes. But the nice thing being that we can use the function multiple times in different contexts, and it just works. So we can just create my other variable is equal to multiply by 2 and pass in, we can just pass in the number 10, and that would print out 20 if we print out my other variable. just run it for proof. Alright. As a quick note, this is a bit of inefficient function. This can be done a lot simpler. So go ahead and duplicate it. Multiply by 2 efficiently. So a couple of things. We don't have to create this variable, right? Instead, we can just say return my parameter times 2. The other option as well, see if I can undo this, is a lot of times you will want to change some variable and assign it to a new variable by performing some basic arithmetic on it. What you can do is, instead of creating a new variable, you can just alter your existing one. So we can say my parameter times equals 2. And that is the same as saying my parameter is equal to my parameter times 2. So that works for times, plus, minus, just the various mathematical functions, where you are changing the value, referencing its past value, and doing something to it. Alright. So let's just change this to the simplest format and call it good. Alright. An important thing to note about functions is they have to be defined before they are used. So if I try to put this before it, it's going to complain and say, I don't know what multiply by 2 is, because we haven't defined it yet. And you can see that if you run it, it's going to give you, yeah, multiply by 2 is not defined. So you can just define all of your functions at the top if you want, however you want to do it, but it won't work if they're below. Alright, so next up are objects or classes. So Python is an object-oriented language. It's based on creating objects that have some level of permanence and altering them in ways so that you get your desired results. So the way that you define a class is just with the class keyword. Call it whatever you want and put a colon. Classes by default come with a function that you can call when you create one called init. Which takes a single parameter called self. And we'll come back to this in a little bit. But for now, just think about the things a bike has. It has a speed, and bike start at speed 0. It can have a direction if we want, forward, and maybe they have a name, bikey. So classes or objects have some traits about them or properties. You can also give them some functions which will only be accessible to the class. So you can have accelerate, have it take in itself and some value x. Say when we call that, speed is going to increase by x, or change by x. Yeah, self.speed. Can rename equals new name. And let's say same name. We'll just say print I am self.name. Alright. So we have a bike, has some properties and some functions we can call on. So we're going to create a new variable, my bike, and say it is a bike. So this is how we create an instance of a bike. So it looks a lot like a function, but it's just a constructor function for this bike. So when we execute this, it's going to go to this init function, and it passes in the self without us putting in anything. So it's just a reference to this instance of the bike. So it says, alright, bike has speed equals 0, direction equals forward, name equals bikey. And it calls it good. So we could then just say print mybike.speed, and it's going to look at this and see what it is. So just go ahead and run that. Well, let's try mybike.say name. Oh, okay. That's the issue here. Alright, that should fix it. There we go. And I forgot a space here. Make that a little clearer. Okay, so now we could go. So as you see, its name is Bikey. An important idea here, though, is that when you create a bike, it's an instance of a bike. So you can have multiple instances of a bike. They would all have the same types of properties, but not necessarily the same values of those properties. They'll all have access to the same functions, but the functions only affect the bike you are calling it on. So to make that a little clearer, we'll say we have two bike variables. And we'll say my bike, well, let's do this, print my bike.speed and print my fast bike.speed. And before we hit these functions, let's say we call accelerate on my fast bike, and I'll accelerate at 10. So what we should see is that my bike has a different value for speed than my fast bike, because they're two instances, they don't share, the functions don't work on each other. We're only calling accelerate on my fast bike. So the next thing we're going to talk about is scope. So that plays into classes and functions a bit. And the idea is that my fast bike has a concept of what speed is, and so does my bike, because speed is a variable of the bike class. But outside of that class, the rest of my code has no concept of what speed is. If we print this, it's going to Yeah, say speed is not defined. I can make a variable called speed. And this will work now, but this could be confusing in your code. So this speed applies to your entire program. We can access a more specific variable speed by accessing it through an object. And the same can go for functions, like in here we're passing in new name. That's just the parameter for that function. We can create a variable out here called new name, and then we can change, we'll say my bike.rename Slowy. Print my bike.say name. Get rid of these. And so this name, new name, is different from this parameter, new name. And they don't overlap because they're in different scopes. They have different levels of visibility. Next up, we're going to go over some basic logic. So logic ties back into the basic data types of Booleans. It's essentially a way of asserting whether something is true or false. So this is where Booleans become important. So let's say I've got two variables, say A and B, and I want to check if they're equal. So equality is reducing these variables to a Boolean statement. Actually, we'll just say my bool equals, parentheses, A. This is saying, is A the same as B? And my bool will either be true or false. In this case, it should be false. So double equal sign is checking for equality. Single equal sign is assigning value. And that's something that is pretty easy to mess up. So we have a couple of different basic Boolean statements. We have equals, not equals, greater than or equal to, less than or equal to, greater than, and less than. We can also combine different Boolean statements and make them arbitrarily complex. So we'll say my bool is going to be equal to A is greater than B, or A is greater than 0. And if we run that, it'll print out true. So what this is saying is one of these two statements, as long as one of them is true, my Boolean is going to be true. We also have AND, it's the other combiner, which is only going to make my Boolean true if both of these statements are true. So in this case, A is not greater than B, but A is greater than 0. But since they're not both true, it's going to be false. And so you can combine an arbitrarily large number of Boolean statements and combine it into one. You can also negate a statement by saying not. So in this case, This is saying if this is false, or rather, if not a greater than b ends up being true, and a is greater than 0, this is true, then everything is true. So this should be true, and it is. So well, actually, I'll leave that. The main use case of Booleans, in my opinion, are with flow of logic through code. So we can say if such thing is true, say if a is greater than 0, then do this. Otherwise, or else, do this. So only one of these two lines is going to be executed. In this case, a is greater than 0, so it'll execute the first one. If we instead change that, we say if not a is greater than 0, this is not going to evaluate, so this will. We also have a third option of control statement, the elif, which stands for else if. We can make this one pretty specific. B is equal to 10. And so the way this works is, again, if this is true, this will evaluate, and none of these other ones will. This only happens if the if statement does not get, if that evaluates to false, then it'll move on here. If this evaluates to true, then this happens, and this does not. The final else statement will only occur if all of the preceding statements evaluated to false. And again, these can be arbitrarily complex, and if for some reason you want it to pass if the statement is false, you just throw a not in front of it, because that negates the truthfulness of the statement. So that is Boolean logic. So pretty useful to execute certain code only under certain conditions. The next thing is loops. Oftentimes in code you're going to want to kind of go through multiple sections of code multiple times without it necessarily having to be a function. So the way you do that, one of the most basic, is a for loop. And so we'll do this. We'll say you want to print out every number up to 5. And it looks kind of like a function, and it behaves a lot like one. So we're saying x is kind of our parameter here. It's whatever variable we're assigning it. This function range is built into Python. There's a couple of other functions that are just built in, you get for free. So in the range from 0 through, but not including 5, assign those values to x and then do this to it. So we should see 0 through 4 pop up, and we do. And so, we can change the range to take in a variable instead, and it'll work the same way. So it's a good way to run code multiple times. And we'll come back to this in a second. So there's a more complex data type available, a couple of more, but the one I'm going to go over right now is called lists, a list. So lists in Python are ordered and don't have to contain unique variables. It's just a collection of multiple different values. So you can have strings, integers, booleans, all of them inside of this list. And if we print it out, it will just be in the same order as we create it. And so again, these quotations identifying the strings, separating them from the booleans, have the same value in there twice. You can also use variables, contain variables. Go ahead and print that off again. And notice it prints the value of the variable, not just the variable name. Lists can be any size, can be empty. And using the loops, you can iterate through them. So if we say for list item and lists, print list item, it will do the same thing as this print when we just printed it out essentially, but they'll be on different lines. So let's comment all that out. You can do some interesting things with that functionality. So say we have an int list 1, 2, 3, 4. You can say for x in int list print 2 times x. So this should print out a doubled value of our list. Yeah, so 2, 4, 6, 8. Going back to our initial basic data type, strings. Strings are treated in a very similar way to lists. And you can see that by throwing one into a loop. Oh, there we go. Yeah. And so anything that you can do to a list, you can pretty much do to a string. And so for example, you can get the first letter of a string or the first item of a list by accessing it using this notation. So go ahead and just comment that out, and that should print out the first. Lists start at 0 and go up, so this is 0, 1, 2, 3, 4, 5, even though it's 6 in length. Just to demonstrate that they're the same, you can print out the zeroth item of a list as well. Oh, yeah, A is not defined. Alright, well, if we make our list valid, it'll work. There we go. So let's actually go back and access our int list. If you want to do you can do interesting things with lists and strings without having to loop through them as well. So go ahead and get rid of this. in our earlier example we doubled the value of each thing. We can do that much more simply just by using our shorthand. Say int list times equals 2 and print it list, and that is just going to double the value of everything and store it back into int list for us. Oh, well, okay, never mind. It's going to double the list, and it would do that to a string as well. Let's try. Yeah, okay. I guess you would have to loop through it. My mistake. But regardless, you can apply arithmetic to lists and get some interesting results. So we already went over that you can access individual variables in a list or a string by indicating which index you want to access. You can also have a start and an end index. So this is going to access 1 through and not including 3. So it's going to bring back 2 and 3. This would bring back the entire list. Then there's also a third parameter you can add called stride, which is how many to skip. So in this case, it's going to say I want from 0 to 4, and I want to grab every second item, 1 through 3. You say every third item, in which case it would only return 1 value. Oh, never mind. Yeah, that makes sense. Every fourth value, that will return 1. And then this can also be negative. We'll say if you can just put in a colon for each. Well, so this is shorthand for give me the full list, but give it to me backwards. There we go. Conversely, you can also access, so if this is the 0th, this is both the third and the negative 1th element. So you could say negative 4 to negative 3. There we go. And so that's how you, yeah, it seems weird in this instance, but it can be useful in some data manipulation senses. If you want to grab from the second to the end, you can use shorthand and just say 2 to the end. Alright, so that those are all the basics that I've already covered. In theory, you can pretty much make any program using the stuff that I've gone over here. Maybe not beautifully or easily, but it can be done. And the most important part is just practicing and trying out new things with code. So just I give a couple of suggestions about basic programs that you can try to make with these. So first off is just a die roller, where it just generates a random number between 1 and 6. Another one is a pig Latin translator. That one, just take a string and change it and then print out the actual pig Latin translation of it. Let me see, there's another one. rock, paper, scissors, where it calculates the winner given two scenarios. And pretty much with any basic program, if you just look up how to do it in Python, die roller Python, you could just copy and paste code off of Stack Overflow, which is like the main, it's like the Wikipedia for coding. But understanding how that code works is more valuable than just getting code that works, I would say. And so if you find something that works, try to mess around with it, with a die roller, change it to be a 12-sided die, or maybe instead of numbers, it's letters of the alphabet. Just mess around with and mess around with existing solutions, see what you can make. In addition, next time I'll go over input and output a little bit more in depthly, but essentially you can capture user input just by saying input and then prompt. And you can just assign a value to it. And let me try that again. Sure, input 10. And sorry, we'll use print x. Yeah, so that's the simple way of getting input, and you can look into more complicated ways. So with paper, rock, scissors, for example, you can try that out. Let me know if you have any questions. This was not the best tutorial probably that I've made, but hopefully it'll help. And if you're having any issues getting your environment set up, whatnot, just let me know. I'm happy to help out. Thanks.